Okay, there. All right. So we're still on 1.6, still inside 3. We're just moving through all of the cards. So this is A6. Okay, so for A6, it says the relationship between the speed of a car and the distance it takes to stop when traveling on that speed. Ms. Johnson, they gave you a table. The table, what do you do now if they gave you a table? Okay, if they gave you a table. Okay, so if they gave you a table, what do you do first? So a couple of things, I kind of look at it and say like, oh, 10, 20, 30, 40, 50, 60. Okay, they're going by tens. And over here, it's growing, but I don't know by how much. So what I'm going to do is I'm going to look for those, either the differences or figuring out how much it's growing by, right? So let me go over here to my little thing. Let me go over here. So the first thing I'm going to do is I want to figure out what shape is this? Is this a line? Is this a parabola? Is it an exponential? Who are you? Kind of thing. So I'm going to subtract these differences here, and I'm going to use my help calculator. I'm not using the Desmos calculator just because this is subtraction. So I go 50, take away 12.5, and I get 37.5. So 37.5. This is a plus. And then I'm hoping that it's the same 0.5 minus 50. Oh no, this is a different number. So so here, this is not a constant difference. And some of you are thinking, but Ms. Johnson, over here, it's not going up by one. So that's okay. As long as this increment is the same and this increment is the same, being added every single time, then that would tell me that it's linear. So shoot, this is not linear. Okay, so then that kind of goes away. I don't know why, but it's not catching up. So give me a second. Let's let that catch up to me. Okay, and then so the next thing I'll do, yeah, I'll look for the constant difference, but because these two numbers weren't the same, like in my own brain, I'm saying, you're not linear. You aren't linear. So meaning it's not going to be a line. So if this is not a line, then what shape is it? So then I'm going to bring out my handy dandy Desmos, right? I'm going to bring that over here. And then, I don't know where this thing is. There it is. And then this guy. So I want to bring out my handy dandy calculator, my graphing calculator, this guy. And I want to graph that. So I'm going to graph those points right there. These points here. So I don't know if I've shown you this, but I would rather graph this in a table because it's just easier to enter. So I hit plus, and then I hit table, and then I'm going to turn this off. I'm going to enter all my X's. So 10, 20, 30, 40, 50, 60, right? Can you guys see that there? And then here, I'm going to enter in all of those. Yes, thank you, thank you, thank you. Someone already told me what type of graph this is. Very good. Someone said, hey, Ms. Johnson, I think it's a this. I'm just showing you what I do, just so that in case you didn't have any ideas, that's why I know it's this. Okay, so there it is. And then you look on your graph and you're like, Ms. Johnson, I don't see any points. That's because the points are outside my window. So what I'm going to do is I'm going to maximize this, and I still don't see them. So I'm going to start zooming out. Oh, there they are. There's some points right there. Okay, so zoom out some more, zoom out some more. Oh, it looks like this. So this shape reminds me of, nope, not that guy. Sorry, my bad. That shape reminds me of this guy, but the other way. So this is an exponential. So you're telling me, Ms. Johnson, I should be on the lookout for an exponential? Yes, please go look for an exponential. So where's that little card guy here? So I'm looking for an exponential, right? This kind of looks like it right here, right? 1, 1 doesn't make sense. Oh, you guys can't see my table. 1, 1 doesn't make sense as my exponential. And then 5, 15 also doesn't make sense, because if 5 is over here, then it would be that, right? Yes, yes, yes. So someone's saying, Ms. Johnson, so it can't be that one because that's not exponential. It could be this one. but it's not that one. So it's in between these two right here. So I'm going to look at this one and look at the points that it gave me and see if those match. So this one says 20 comma, and it looks like halfway in between to the 100. So that looks like 20 comma 100. I mean 50, my bad. And then this one says, let's see, 20, 40 comma 200. And that's exactly right. And we're off to the, okay. So notice how this one is B5. Very good. And a lot of people told me that it wasn't that I was being stubborn and not listening to you. I'm just showing you where my brain is thinking about stuff. Okay. All right. So this next guy, card A7, looks like this, and it's the relationships of the dots in time. So you guys know where I'm going to head to. I'm going to head to a table because the table is going to help me write this out. So I write a table, and the first one is 1. This is T, and this is dots. So I get 1, 1, I get 2, 3, I get 3, 6. That's 6, yeah. And then 4, and I get 10. And I'm like, wait a second, I think I remember hearing these numbers. Oh, I never put these together. So shoot, B5 needed to be matched with A6. B5, A6, boom. All right, let's move you over here. Oh no, don't go together. Do not go together. These two, right? So that's that. So I'm gonna work on this guy right here. And if you look, that's exactly the chart, the table, the table, the table, the table, right? So that means it's B8. Very good. Awesome work. You 3, 1, 2, 3, 4. 1, 2, 3, 4, 5 of you. Very good. So this guy matches with this guy. Boom. Done. Okay, so what did I just say? B8 matches with A7. And so now, do you notice how they're becoming a little bit easier to pick out? Because number one, we've already correctly matched all those other ones. And now we're moving forward to the other thing, okay? So then I'm going to move on to A8, and you look at this one and just look, if you only have these 3 left with these 3, and we're dealing with this like 15% guy, what do you think has to happen for this one? While you do that, I'm going to collect my participation. Lisa, oops, sorry. Very good. You guys did a lot of good work today. Okay. So just by looking at this, I'd have to guess that this guy here, the rate of at which caffeine is eliminated from our bloodstream of an adult is about 15% per hour. The relationship between the amount of caffeine in the bloodstream and the number of hours from the time the adult drinks the caffeine is about 500. So wait a second. I remember that there was like this 500 number that I remember this 500 number because that was one of these. So it can't be this one, right? Because there's no 500, no 15 there. No. And this one is, let's see. I don't even see 500 on my graph. So that's probably a no too. But this one has a 500. But this one has a 15%, and this is 85. And you should know that those two match up together, right? Because 15% to make it a whole would be 85%. Okay, thank you. Okay, so I'm gonna put if you guessed that A8 and B10 match, you are absolutely correct. And I will say this, I unmatched them. The reason why they are together is because this 15% plus the 85% actually makes 100%, right? And so the reason why this is 85% is they asked you for the amount of caffeine in the bloodstream, where this 15% is talking about how much is leaving the bloodstream. So 15% is leaving the bloodstream, that means 85% is left. So this is actually how we write 85% in math. So that's why that's there. Very good. Very good. Very good. Okay, so then what I have left are these. And let's see, they're both quadratics. I'm a little nervous. Okay, so I know that this one and this one don't match because those two functions don't match. So it must be that these two match. and these two match. And I'm actually going to check that. And you could check this by graphing it. You could check this by using a table. So these two match for sure. And then this one says Mary wants a rectangular flower garden that is 6. Aha, there's that 6, right? Meters wide, or 6 meters longer than it is wide. Oh, so a rectangle is length times width. Do you guys all see this? This is length times width here, length times width, right? So there are your matches for the whole entire thing. So hopefully that makes sense. I'm gonna pause this right here.